universe today is not the same as yesterday. At every passing moment, there are very small but significant changes happening even if we are not aware of them. The universe is expanding. The distance between cosmic structures is increasing over time, until eventually the universe will die in coldness. Unfortunately, nothing can change this fate. A second ago, the universe was a bit smaller. A second from now, as you think about this, the universe will be a bit larger. These subtle changes occur at macroscopic levels compared to which humans are merely atoms, unable to perceive them. As the universe expands, the radiation, matter, neutrinos, temperature, and dark energy within it all change. What we observe in the sky will also change significantly. There are 6 different eras in the development of the universe since the Big Bang. And unfortunately, we are living in the final era. Scientists divide the life cycle of the universe into eras because the universe is continuously expanding. This chart shows that everything existing in the universe has a certain amount of energy, such as matter, radiation, dark energy, and dark matter, etc. As the universe expands, the proportion of energy density that these components occupy changes, each with a different development as the matter we see in the top row, energy and radiation in the middle, and dark energy at the bottom behave differently in various cosmic eras. While the density of matter and radiation both decrease, dark matter and dark energy remain unchanged. The longer the universe exists, the more it will expand. In the future, the temperature of the universe will decrease, unlike the past which was there. Stars, hot gases, and matter that were once chaotic will become localized clusters, like the solar system or galaxies. Additionally, of course, the universe will be much larger in the future. By applying known physical laws, comparing feasible solutions with observations and measurements obtained, humans can determine our origin as well as our destination in the vast universe aboard the blue ship that is Earth. We can extrapolate our past history from the beginning of the Big Bang and even before, up to the period of the universe's continuous expansion. We can also extrapolate the current universe to see the final fate awaiting in the distant future. Theoretically, the development of the universe can be understood thanks to Einstein's relativity theory when the laws of space-time have been proven. In the future, we will still receive distant light from galaxies in the past. But the speed of light itself will limit us to a visible distance of 14 billion light-years, which is the age of the universe. Beyond that distance, light will never reach us because we ourselves are moving away faster than the speed of light. When dividing eras based on the characteristics of the universe, there are 6 different eras that the universe will go through. The first era, the pre-expansion epoch, when the Big Bang had not yet occurred. Next is the second era, the primordial epoch, at the beginning of the Big Bang. Until the last nuclear interactions occurred in the early universe. The third era, the plasma epoch, ending nuclear interactions and particle scattering, until the universe cooled enough to form neutral particles. The fourth era, the dark age, from the formation of neutral matter until the first stars. Galaxies reionize neutral particles into non-neutral particles in the intergalactic space of the universe. Next is the fifth era, the stellar era, ending the reionization process. Until the formation and growth of large-scale structures ceased, and dark energy density dominated over matter density. Finally, the sixth era, the dark energy epoch, this is the final stage of our universe. When expansion accelerates and objects become disconnected from each other, they will drift further apart, gradually sinking into dark space. White dwarfs, the remaining remnants of dead main sequence stars, the last light of the universe has all gone out. The universe is plunged into eternal darkness. When a main sequence star, if it does not have enough mass to explode into a supernova, it will become a white dwarf. A star dies because it exhausts its hydrogen and helium fuel. However, a white dwarf will still be hot and glow for a very long time. Just like an oven still emits heat even after being unplugged. After a while, all remaining heat will dissipate. At this point, when no longer emitting light or heat, white dwarfs will become black dwarfs. The future evolution of stars depends on many physical issues that we do not fully understand today, such as the nature of dark matter or proton decay phenomena. Therefore, the time required for a white dwarf to become a black dwarf is still not agreed upon. But according to astronomer Heat and Sears calculations, a white dwarf needs at least 100 million trillion years to cool down and become a black dwarf. Although we will never see or experience a black dwarf, we know enough about their nature to not only know that they will exist but also how and when they will exist. And this itself is one of the most amazing parts of science. In summary, humans have entered the final era that began billions of years ago. Most of the important events that define our cosmic history have already occurred. And then, the end of the universe comes, when only black dwarfs, small isolated masses of matter, that's enough for nuclear fusion to occur spontaneously within them, will remain. Galaxies become sparse and disconnected from each other in the ever-expanding empty universe. These final state dead stars will exist for many years thereafter, and they will be pushed apart, as dark energy remains the dominant factor in our universe. Dark energy has driven the expansion of the universe since 6 billion years ago and began to dominate around the time our solar system and sun formed. They play a crucial role when the average density is much lower than matter, but dominate the entire universe because they are not concentrated like matter. In terms of uniform density, dark energy is present everywhere in the universe. Scientists have proven that most of the universe is dark energy and dark matter. While dark matter slows down the expansion, dark energy accelerates it. Dark matter functions similarly to gravity, binding the universe through gravitational interactions but does not reflect, absorb, or emit light. In contrast, dark energy is a repulsive force, existing as anti-gravity that drives the increasingly rapid expansion of the universe. Humans are only an extremely small part of the universe and cannot fully explore this vast cosmos, especially not knowing for sure what is enough about the immense universe outside. The universe may undergo 6 stages, but unfortunately, the entire history of Earth falls into the final stage. Let's observe the universe around us and cherish its current beauty, because after many more billions of years, the universe will no longer be as vibrant and full of life as it is today. Certainly, after many more billions of years, the universe will no longer be as colorful and teeming with life as we are witnessing now.